Good evening, everyone. Welcome to day 2 of FDP on Progressive Safety Engineering Strategies and Manufacturing and Industrial Applications. Myself, Indugala, FDP Coordinator. And let me introduce today's resource person first. It is my personal privilege and honor to introduce our esteemed resource person for today's session, Dr. Maya G, a distinguished academician and researcher in the field of electrical and electronics engineering. Dr. Maya G completed her PhD from National Institute of Technology, Calicut in 2016 with her research focused on design and implementation of supplementary damping controller for mitigation of inter-area oscillations using FACS devices. Her work makes a significant contribution to enhancing the stability of power systems through advanced control strategies and flexible AC transmission technologies. She holds an MTech in Power Systems from the College of Engineering, Trivandrum, Kerala, and a BTech in Electrical and Electronics Engineering from NSS College of Engineering, Palakkad. Currently, she is serving as an associate professor at MES College of Engineering, Kuttipuram, Kerala, and she has been associated with several renowned engineering colleges across Kerala in various capacities. She is not only an accomplished researcher but also a passionate educator. Dr. Maya has actively participated in numerous faculty development programs, international seminars, and national level workshops, consistently staying at the forefront of technological and pedagogical advancements. She has been a proud member of IEEE since 2011 and an active contributor to the IEEE Women in Engineering Network since 2014. Now, if I may add a personal note, it is a special moment for me as I have had the great fortune of being one of her students. I hope she still remembers me as a student, and I can confidently say that the lessons I have learned under her guidance have left a large impression on my academic and professional journey. We are truly honored to have you here today to share your expertise with us. Dear participants and colleagues, join in extending a warm virtual welcome to Dr. Maya Ji, today's team resource person. Thank you.
Thank you very much, Indu. I surely remember you as a good student of mine. Thank you very much.
Thank you, ma'am. Thank you, ma'am. Shall we start the session?
Yeah. First of all, let me thank Indu as well as St. Mary's Polytechnic College for inviting me to this particular FDP, ATAL FDP. Actually, the topic given to me in the session is electrical safety in industrial environment, basics and best practices. As Indu has already told, I'm working as associate professor in Department of Electrical and Electronics Engineering in MES College of Engineering, Kuttipuram. So, what is industrial safety? Industrial safety, it is a discipline which is focusing on designing and managing systems to protect workers, public, environment, and assets from harm. Okay. Previously, we were just focusing on protecting the workers from harm. That is, it was like reactive. Whenever there is a chance of harm, we used to act accordingly. But it is about proactively preventing accidents and not just reacting to them. So now, as industry is growing day by day, we have to proactively protect our assets, workers, public, and environment. It's a matter of life and death, not just intellectual exercise. We have seen so many disasters in last few decades. So one of such disaster was the Piper Alpha case, where uh, a pressure safety valve was removed from the pump and a temporary cover was put in place of the seal to seal the open pipe. And in the oil rigs, there will be shifts, and the new shift was unaware of missing safety valve, and they attempted to start the pump. So this caused a massive gas leak, which quickly ignited and led to a series of explosions and fires. From there, we could learn lessons, and Sir Brain said that safety is not just an intellectual exercise to keep us in work. It is a matter of life and death. It is a sum of our contribution to safety management that determines whether people we work with live or die. And we know that in India, the world's worst disaster occurred in the year 1984 at Bhopal, the Union Carbide India Limited. There was an explosion in that particular industry. So in this particular case, there was a leakage of water into the methyl isocyanate tank, which was around 40 tons capacity. So when the water leaked into the MIC tank, an exothermic chemical reaction took place, which was uncontrolled and causing a rapid increase of temperature and pressure. The tank release valve eventually opened and released deadly gases into the atmosphere. And this incident caused almost 2,500 deaths and around 5 lakh injuries. So we can conclude that safety is such an important topic when we consider the industry, and we'll deal with some of the terminologies regarding the safety. Safety, it's a safe state of being free from risk or danger, and from which particular event we have to safeguard ourselves. That is called hazard. That is the potential harm which will be caused. That is, when we consider electrical system, an exposed bus bar is a hazard. So the next terminology is risk. It's the product of probability of mishap and severity of its potential consequences. And the mishaps are otherwise called as accidents, which are undesirable and unexpected events that results in injury or damage or even death. There are events which may not cause injuries or death, and such events are called incidents. So what is hazard theory? When this hazard becomes a mishap, the transition that is shown in the figure. So hazard means it's a state before a potential accident occur. That is, it's a potential condition before accidents. And the transition is from hazard to accident, that is after stage event, which is the actual consequences. Okay, so the elements of hazard transforming to mishap are the hazard component, and the risk factors. So let's consider a small example and see how a hazard can be transformed to a accident, or how the transition takes place. So let's see. Uh, a worker could be electrocuted by touching exposed contacts in electrical panel containing high voltage. So we can see a worker, a person could be electrocuted. That is the target. We are trying to protect our worker, assets, public as well as environment. So those are our targets. Here, the worker is our target who could get electrocuted. And how he is going to get electrocuted? By touching the high voltage, by touching the exposed contacts. So those are the initiating mechanism by which the worker will get electrocuted. And the third one, it is due to the high voltage by which the worker will be electrocuted. So high voltage is a hazardous element, and the person who is getting electrocuted, that is our target, and the intermediate components are initiating mechanism. This is how a hazard triangle can be represented, and in total, this is how a hazard is represented. Okay. So there are three elements in hazard. That is hazardous element, the initiating mechanism, and target and threat. So hazardous element, this is a basic hazardous resource creating the impetus for hazards such as a hazardous energy source such as explosive being used in the system. So in the example, it was high voltage, which was the hazardous element. Initiating mechanism. This is a trigger or initiator event causing the hazard to occur. Hazard to change over to an accident. Okay. So the initiating mechanism causes actualization or transformation of the hazard from a dormant state to the mishap state, the transition state. Okay. And target and threat. This is a person or thing that is vulnerable to injury or damage. It describes the severity of the mishap event. Okay. So this is how we can control the hazard. There are certain hierarchy of control strategies. The elimination, substitution, engineering control, administrative control, as well as the personal protective equipments. And elimination will try to remove the hazardous element so that we can clearly eliminate any accident being occurring in that particular industry. Substitution will replace less dangerous alternatives, reducing overall risk. And engineering control. In engineering control will isolate the people from hazardous element using barriers or safety systems. And in administrative control, we are making policies, giving training to the workers, and we actually give regular maintenance work to change the work practice. And personal protective equipment, this is the final line of defense and reduces the exposure of the worker to the hazards. So elimination, an example is given, that is designing work to be done at ground level instead of scaffolding to eliminate the fall hazard. Okay, this is a civil engineering example. And substitution, we can replace hazardous element by a less dangerous one. Usually we'll use solvent-based paints. Instead of that, water-based paints, if we are using, there is a less risk. So we can eliminate, we can substitute with less dangerous elements. And engineering control, uh, the machine guards, ventilation systems, and soundproof enclosures make a example of engineering controls. We can see electrical machines are covered. There are guards in the outer. So this is a engineering control. Administrative control, job rotation to limited exposure, and safety training has to be given to workers. Warning signs have to be put wherever it is required so that the worker or external persons can identify the hazards in a particular industry. The personal protective equipment. So providing protective gears to workers to reduce their exposure to hazards like helmets, gloves, goggles, and respirators. This is the least effective control method because its effectiveness depends on proper use and maintenance of it. So these are the hierarchical hierarchy based on for hazard elimination. Okay, so industrial electrical safety overview. We can see critical safety challenges where industrial environment present unique electrical hazards with high voltage systems. So now we are going into detail of electrical safety. So complex, we know high voltage systems are all over, and complex fault currents occurs. Depending on the location of the fault, the component or element where the fault is occurring, the risk factor is also changing. We know nowadays the power system is a multi-source energy, is having multi-sources, and the complexity of the power system is increasing. So specialized protection strategies have to be formed. The fault current can go up to 65 kiloamperes in the distribution, and complex hazards like arc flash, shock, fire, arc blast, etc. will be occurring. So these are the basic electrical hazards: electric shock, arc flash, arc blast, fire. So electrical system causes several significant hazards in the industrial environment, including the high voltage and high fault current. So we'll deal with these basic electrical hazards first. So what is an electric shock? So current through body causing injury or death is called the electric shock. And the severity of the electric shock depends upon the magnitude of current flowing, the duration, and the path. Arc flash. When arc flash occurs, plasma reaching 20,000 degrees Celsius with incident energy greater than 8 calories per centimeter square will be occurring. Arc blast. It's condition when the pressure increases and the copper will be expanding quickly and throwing away the worker who are nearby, and the noise will be rising up to more than 140 decibels, causing hearing damages. Electrical fire, also overheating, loose connections, insulation failure causing ignition and fire spread. We can see many disasters where electric fire has occurred due to loose connection or installation failures. So these are the pictorial representations. So electrical shock, as I said, electrical shock occurs when electric current passes through the body, and the severity depends on the current's magnitude, duration, and path through the body. If our body is wet, then the body resistance decreases, leading to higher current flow and increased severity. According to the current magnitude, the severity will be changing, and we can see if it's 1 milliampere, it's as small as 1 milliampere, the threshold of perception will occur, and if it is around 10 milliampere, it can cause painful shock and muscle contraction. And around 30 milliampere, it will lead to respiratory paralysis. And if it is more than 100 milliampere, ventricular fibrillation, and this will cause maybe death. So arc flash. Arc flash, it's a dangerous electrical explosion caused by high current arc across an air gap. So the plasma can reach up to approximately 20,000 degrees Celsius, and there are boundaries defined for arc flash. The arc flash boundary is the distance from the equipment where the arc occurs, where an arc flash could cause a second-degree burn. Okay. From the equipment, if we are moving outwards, it's the distance from that equipment where second-degree burn can be caused. And limited approach boundary is the boundary that is defined for workers without specialized training. They can enter till the limited approach boundary. And restricted approach boundary, that is for specially trained workers performing the energized work. We can see in this particular diagram, this is the exposed conductor given, and the red zone shows a restricted approach boundary. Only the specially trained workers can cross this particular boundary when the worker is performing a maintenance on the energized equipment. Okay. And in the orange line, that is a limited approach boundary where workers without special training should stay outside this boundary unless they have appropriate protection and are escorted by a specially trained person. And the final boundary, almost an yellow one, the arc flash boundary. This is the distance from the equipment at which an arc could cause second-degree burns. Unprotected workers should keep clear from these boundaries. Next is arc blast. The arc blast is the pressure wave generated by an arc flash. So here the pressure, as I said, the pressure will exceed beyond 1000 Newton per meter square, and it will throw the worker away, and the noise can go beyond 140 decibels. Next is arc electrical fire hazard. Electrical fire hazards are caused by overheating of conductor, loose connections in insulation failure. The arc fault can also cause ignition. So the certain mitigation devices for electrical fire, that is arc fault detection devices, AFDDs, the thermal imaging to identify hotspots, we can see in the picture, and the fire resistant cables. The hazard mitigation and protection, how we can mitigate these hazards and protect the worker from the hazards. Hazard mitigation and protection in electrical safety is a layered approach to prevent accidents and minimize the harm. It focuses on controlling hazards at their source and implementing safeguards to protect people as well as the equipment. So we are mainly focusing on the engineering control. Engineering control, we are giving the proper grounding and bonding, the guarding and barriers are defined, as well as the arc mitigation. These are the different methods followed under engineering control. So grounding, bonding, and earthfall protection. Grounding provides a low impedance path. We know current flows through the low impedance. So whenever a fault occurs, it should flow through this grounding ground wires through to the fault. So grounding provides a low impedance path for fault current, reducing the touch voltage. There are different methods, that is solid grounding, resistance grounding, and reactance grounding. Solid grounding, it is directly connects neutral to the ground, and resistance grounding, it will limit the fault current, and finally the reactance grounding, they are used for arc suppression coils. The different applications, these methods are used in different applications, and the grounding usually connecting the electrical system or equipment to the ground provides low resistance path for the fault current. The bonding, it is connecting all the metallic enclosures, interconnecting all metallic enclosures, conduit structures, etc., so that they are having equal potential and prevents shock. Example, a motor frame conduit and nearby pipes can be bonded together, so no potential difference exists between them. So this particular chart gives the three methods and their comparisons. So solid grounding, resistance grounding, and reactance grounding. Solid grounding, it is directly connects neutral to the earth, and whenever high fault current, it is used for high fault current, simple protection schemes are applied here. And resistance grounding, they reduces the arc flash energy, and they are usually applied for industrial medium voltage applications. And reactance grounding, they are used in distribution network. So next is the barriers. Barriers, they are called lockout or tagout in simple LOTO procedures. So here the steps followed are the preparation, shutdown and isolation, lockout and tagout, and verification. That is, when a worker is going to give any maintenance to a particular equipment, he has to first of all identify all energy sources and isolate points for the equipment. That is the preparation to be done. And once the sources are identified and isolation points are points for the equipments are done, then power down equipment and isolate using breakers and valves. identification is done, then we have to power it down. After powering it down, we have to keep a lock to prevent accidental re-energization. That is called lockout and tagout. So we'll keep a lock and we'll tag that the maintenance is going on in such and such equipment. Then the verification has to be done. We have to assure that there is zero energy before testing the equipment. That is our verification process. So whenever preparing for shutdown, perform shutdown, we have to locate and disconnect all the energy sources, place the locks and tags, then release or block any stored energy, de-energizing, verify the lockout, and then perform our services. After performing our services, we have to undo our lockout and tagout. These are the procedure to be followed. So arc flash mitigation process we have done with the grounding, bonding, we have done with the barriers, and finally the mitigation method for arc flashes. There are different methods. The 5 methods displayed are arc resistant switchgear with pressure vents, the optical arc detection release, the zone selective interlocking, ZSI, smart earthing and advanced monitoring, and finally the remote operation and racking system. Arc resistant switchgear. So our equipments should be designed in such a way that it can withstand internal arc faults without rupturing. So this is one such switchgear, and it is equipped with pressure relief vents to channel gases safely away. This will protect our operator standing nearby the switchgear and prevents catastrophic failures. Next is ultra-fast arc detection or the optical arc detection release. This particular release senses arc light within 1 to 2 milliseconds and triggers immediate breaker trip. Once a fault is recognized, it has to be the circuit has to be broken by using the breakers. So we need to give the trip signal to the breaker. So within 1 to 2 seconds, this relay senses and gives a trip signal to the breaker to minimize the incident energy. So hybrid relays combine light and overcurrent detection, both light and overcurrent detection to avoid false trips. Greatly reduces PPA category requirement and arc flash severity. Next is zone selective interlocking, ZSI. Usually what happens in every relay will have an intentional time delay. In this particular case, we'll avoid that particular intentional time delay, and the protective relay communicates to determine fault location. Okay. Once the fault location is detected, the breaker or the relay closest to the fault will trip instantaneously. We can see in the first figure, it provides fast clearing without losing selectivity. Here, in the first figure, only this particular circuit breaker near to the fault will be open, the other will be connected to the circuit. So the other circuits or feeders will not be disturbed once the fault occurs. So it reduces, this particular method will reduce the arc flash energy and equipment damage in low voltage as well as medium voltage, and it is more reliable. Next is the smart earthing and advanced monitoring. Smart earthing, the resistance and reactance grounding with real-time monitoring is performed over here. The controls the ground fault current and reduces the arc severity. The condition monitoring, the insulation, thermal sensors, etc. are used. The IoT dashboards with predictive alerts align with the Industry 4.0. We, as there are developments in the AI, artificial intelligence, we are going into the predictive maintenance, and this will improve our reliability and safety. That goes in the next topic, as the next session will deal with the advanced electrical safety. Remote operation and racking system. Remote panels allow breakers operation from a safe distance. So remote racking devices, as shown in figure, will insert or withdraw breakers without exposure, that is, without the exposure of worker to the high voltage or medium voltage system. So keeps the operator outside the arc flash zone during the maintenance. It can also be operated by integrating the CCTV and robotic inspection for safety purpose. So almost all these things were already discussed. So usually protection system, we are mostly relying on the release, protective release. Almost 100 milliseconds for the protective release will be taking 100 milliseconds for the system coordination. Whereas the best thing is the optical arc release, which will operate within 1 to 2 seconds when an arc flash occurs. So testing, maintenance, and inspection. Once we are giving all these mitigation devices, installing all these mitigation devices, it's not, we have to keep on testing and give regular maintenance to these devices. So the grounding was the first topic that we discussed. So there, the resistance is the most important thing. So in the resistance has to be tested. Grounding resistance as well as the insulation resistance has to be tested regularly. And testing method, the first point is the insulation resistance test. Second one, the circuit breakers. We know the electrical circuit is open or closed by the circuit breakers. The circuit breaker has to operate at the time given in that particular specification. So timing test for the circuit breaker has to be done. Next is the relay injection test. That is, relay injection test means we'll give a test truth signal for the relay, so that for regularly testing whether the relay is operating correctly, will give a false thread signal to the relay and see whether the relay is operating as per the current rating and the time rate. Then the thermal imaging of bus bars and cables. Maintenance strategies include preventive, predictive, and corrective maintenance strategies. Preventive, at fixed intervals, will schedule the inspection of each and every point. And predictive, by using the thermographies, we can identify whether there is any chance for arc to occur. Vibration, by using vibration analysis also, we can identify conditions, hazardous condition. And by monitoring all these things, we can predict whether there is a possibility of any accident. Okay. And corrective, after the fault is occurring or accident occurs, we have to repair our equipments associated with the arcs and make corrective actions. So the various devices, circuit breakers, protective relays, grounding systems, and insulation systems, we have to regularly give the tests as mentioned, and the recommended interval at which the test has to be conducted are also mentioned. The standards followed. So in order to safeguard workers and equipments, we have to follow certain practices and procedures. They are, first of all, de-energization and verification. And the lockout and tagout, which I had already mentioned. Inspecting each and every equipment at a fixed schedule or as and when it is required. Using proper personal protective equipments. Maintaining a safe work environment and giving training and competency for the worker. So we'll deal with we had already dealt with the first three. We'll deal with the PPE. So PPE, there are 4 categories of PPE based on the incident energy rating. And in all the suits, the PPE are shown. The levels, the category of PPE is selected according to the incident energy rating. And for high energy systems, we'll be using the highest category, that is category 4, which is having incident energy more than 40 calories per centimeter square. It will be preventing the worker from heavy arc. So we can see certain accidents or disasters where human errors have contributed to such accidents. So in order to avoid such accidents, we have to give proper training to the workers, and we have to give certification for the competency, and reinforcement of such safe practices have to be ensured. So these 2 particular standards, IEC 60364 and NFPA 70E, emphasizes workers training. The training programs should include hazard recognition, choosing of correct PPE for using in particular application, the practical exercises in LOTO, and emergency responses. The refresher courses at regular intervals has to be given to the workers. So these are certain standards, and where it is applied. NFPA is applied to US industries in the US. OSHA is applied for the workplaces in the US. And IEC 61508 is an international standard for the functional safety. Global engineering standard, that is IEEE 15A4. So basic best practices summary we can go to the key safety requirements. That is, the comprehensive electrical safety requires systematic hazard assessment and proper PPE selection. Along with that, we have to give continuous training for our worker. Hazard assessment is done by identifying and quantifying all electrical risks at a particular industry and calculate the incident energy level of the hazard, establishing approach boundaries. And next is we have to give the protection system for such hazards. So we have to ensure that proper device coordination is there and implement the mitigation process, maintain the grounding integrity. Next is the training and the selection of PPEs. The training programs, we have to regularly give training for our workers and update their competency, and safety drills have to be conducted at a regular intervals. Safety culture, we have to encourage reporting and accountability. Whenever a hazard occurs, we have to give proper reporting, and we have to make sure that such hazard or such accidents never occur in a later situation. Thank you. If you have any doubts, I'll try to answer your doubts.
Thank you, ma'am. Dear participants, if you have any queries, you can raise your hands, or if you prefer QA tool, you can use it.